Okay, so a couple of announcements. First of all, the next SAME ASCE student meeting is going to be held on Thursday, the 2nd of October. That's next Thursday, and freshmen are definitely welcome and invited to attend. The meeting's at 5 o'clock, and they traditionally provide food for those meetings. And so if the incentive of getting to know upperclassmen and getting involved isn't enough, maybe free pizza will be. We're going to have a student talk about engineering apparel sales, and you should have received a copy of the order form as you sat down, and so I won't talk too much more about that. But quiz 5, the online multiple choice quiz that you do each week, the one that corresponds to today's presentations will be available until next Friday at 11 a.m. So any questions about those announcements? Okay, well, I'm very happy to introduce our first faculty speaker, the faculty speaker for today, Dr. Asad Salam. He's our division chair of engineering, and his specialty is in mechanical engineering, so I know this is the first time many of you will have a chance to hear from one of the mechanical faculty that we've got at Marshall. So, Asad?
It's not morning yet. I mean, it's over. I could say good afternoon, which is not afternoon yet. Actually, it is. Good afternoon.
Good afternoon.
As Isaac mentioned, my name is Asad Salam. I'm the chair of engineering, and I have some of you in my UNI class. Isaac, our Dr. Wade, with the space station, and I'll tell you something a bit about myself. Space station was an American project when it started, like in late 80s and 90s. Then, due to financial reasons, they switched to make the international space station. I worked in the American market. I worked with subcontractor in NASA, here in Ohio. We did some financial analysis as well. Anyway, as you know that we have a Bachelor of Science in Engineering, and most of you accepted into this program, or planning to our transfer program, or even degree engineering program. But your intention is to stay with us with the Bachelor of Science in Engineering. And some of you may have plans to be civil engineering, or subspecialty with civil engineering, like environmental or transportation or structures. And some of you may be planning to be mechanical engineering. Who's planning to be civil engineering? Easy enough. Therefore, we have good sized students who want to be in civil engineering. And what about mechanical engineering? Okay, that's good. What about planning to transfer from here after you finish the first or second year? I will ask you how much time I have.
5 or 10 minutes.
Okay. Let me ask you, then why you plan to transfer? Because of for a program that you don't have or something? Which program? Biomedical engineering. And I've seen a student over here. Transfer?
Program you don't have.
Which program? Oh, mechanical engineering program. Now, for the mechanical engineering program, our plan is to for a Bachelor of Science in Mechanical Engineering. And at the current time, we have courses for the first 2 years. Hopefully, by the end of this semester, it will become officially that we have mechanical engineering program. We'll cover the full 4 years. Our mechanical engineering program it has some uniqueness in certain ways. It has a co-op component. How do you familiar with co-op? Co-op is a program that allows you, after you finish the first and half, maybe 2 years, to work full-time with industry, where you get training, hands-on experience, for about 6 months. engineering while you are doing your Bachelor of Science in Mechanical Engineering, or also we have a plan to expand that to the Bachelor of Science in Engineering, which is civil engineering as a component. And so, what is the advantage of such program? First of all, give you experience, enhance your opportunity to find job after graduation or even before graduation. Give you some income, because when you work full time in the industry, you are going to earn decent wages, not minimum wage, to provide somewhere around $20 an hour or so. And also, it will help you to graduate faster from the program. Say, how going to be faster? I'm going to take off 6 months from my degree in the first half and 6 months in the other half. That's true, but you have to understand that engineering is more than 4 years program. It's 4, 4.5, 5. Some of you may take longer. This is for our students to make understand engineering more and have appreciation for the field, and even to know which field you are in, and also increase their success rate in the program. If you have any questions, I'm in engineering lab, room 108. Please feel free to come and talk to me at any time. You have my information on our website, or email me or call me, and Dr. Wade will provide my other information. I appreciate the opportunity talking to you, and welcome you to the program.
Appreciate it. Okay, so now I'd like to introduce Taylor Lipscomb, who is going to tell you a little bit about the engineering apparel that you can order.
Hi, can you guys hear me okay? Alright. Okay, there are 2 screen print designs on your order form if you want to look at it while I'm talking. The second one hasn't been approved yet, so you may want to hold off on ordering that one until I know a little bit more about it. But anyways, the rest is all available. We accept check for cash, and it tells you on the order form who to make the check payable to. Also, it says if you mail in the check, it says where to mail it, but it doesn't say where to drop it off if you're not mailing it. So there's a drop box in the engineering labs. I don't know if any of you have classes over there yet or not. Do you? Okay. If you all know Professor Huffman, it says room 111 or 110.
Sounds about right.
Yeah, couldn't remember. But he has a little drop box outside of his door, and once you're done with your order form, if you want to put it in an envelope and put on the outside apparel cell with the money, then you can drop it off in there and I'll pick it up that way. I also put my phone number and email on the order form, so if you guys have any questions, you can just send me a text or shoot me an email, whichever is fine, I don't care. And they're due by the 22nd of October.
Okay, well, I'm very happy to introduce our main speaker for today. Brigham Ash is a former student of mine, and he's a graduate of this program. He earned the degree that many of you are hoping to earn, Bachelor's of Science in Engineering with a civil emphasis. After graduation, he has been working as an engineer at the Division of Highways, West Virginia Division of Highways, in the hydraulics and drainage section. And so I'm very happy that he's here today and has agreed to give his overview of what life is like as a young engineer and some of the projects that he's been working on. So please join me in welcoming Brigham Ash.
You just press F5. Good afternoon. Like Dr. Waite said, my name is Brigham Ash with the West Virginia Division of Highways. So let's go ahead and get started. By the way, I drove by the new building and it's looking really nice. When I left, there was nothing there. It was actually a parking lot. So it's nice to see that Marshall's expanding and they're hoping to improve and expand upon their engineering programs and what they offer. Just a general layout. I'm going to talk a little bit of background, history for me, some of the engineering disciplines, what you do in engineering school, go over the organizational structure of the West Virginia Department of Transportation and within the West Virginia Division of Highways. I'm going to speak a little bit about what I do at the Division of Highways, go over some real projects, show you some photos, things that we're working on, discuss some of the internships opportunities, and do some closing remarks. So I graduated from Marshall University in May of 2011. It was a good experience, helped me to grow a lot. I was real pleased with the level of professionalism of the staff, and they just really pushed us and really helped us to be more prepared for what we were going to be doing for our careers. I was fortunate enough to graduate at the top of my engineering class. Consequently, I followed up by passing the FE. I'm a certified engineer intern. I'm hoping to gain my professional engineering license here in the next couple years. I'll be eligible. As Dr. Waite said, I'm with the hydraulics and drainage unit. I'll go over that further later in the presentation. And just because I'm an engineer doesn't mean that's all that I do. I have other interests as well. I'm looking into economics, I like history, philosophy, and politics is a general term. I'm more of a constitutionalist. I like constitutional law, and I read into those subject matters. So, engineering disciplines. There's 4 major ones annually that are awarded for Bachelor of Science degrees. To make this more interactive, I'd like to have people interject. You can ask questions anytime. And does anybody have an idea of what the 4 major engineering degrees are offered and earned every year? Yep. Yeah, civil is one. Mechanical. No, more of a subset. Geotechnical is a subset of civil engineering. Electrical would be one. And you also have computer. All right, then there's a middle tier of ones that are awarded. Any takers? Okay, that's chemical. More of a specialty as well as petroleum. Any others? Good one. I forgot industrial manufacturing. And then some of you were mentioning specialties. There's a plethora of specialties in engineering. There's a lot of specialty schools. Some of them already been named, and I'll just go ahead and present some of the ones. You also have agricultural. That's generally a forgotten field. There's actually somebody we work with. He actually has an agricultural engineering degree as well as a civil engineering degree. So this is just to show that engineering disciplines, there's a wide variety and a lot of fields you can go into, and should mean that there's a lot of opportunity. So what is civil engineering? Well, it's a professional engineering discipline, but the easiest way I like to say is it's design, construction, and maintenance of the natural and built environment. It's one of the oldest engineering practices, and it deals a lot with the natural sciences. Now, as someone mentioned, geotechnical, I don't know if I heard any transportation. These are subsets of the civil engineering field. You have structural, environmental, geotechnical, water resources, sometimes referred to as hydraulics as well. It's kind of a cross between the two. Transportation, construction, and urban planning. Now, structural, that's pretty straightforward. Buildings, bridges. Environmental deals with preserving our resources, reducing pollution, toxins, water quality. Geotechnical deals with earthwork, foundation design. That's a big key. Water resources engineering deals with transport of water, flood impact studies, mitigation of flooding. Also deals with pumping stations, etc. Transportation can deal with rail. There's some that do some design work in airports. You also have roadway. Those are the three big ones. Construction, that's where the job gets done. On project sites, you have a lot of construction engineers that are there to help manage and make sure that everything's on time and being built to specifications. And then, of course, urban planning. This just deals with any potential city development. They'll also work with zoning permits and help them make sure improve the quality of the community. So civil engineers on the job. What do you think a civil engineer does? I mean, is he always out in the field? Is he sitting at his desk? Any idea? About both? Okay. Is that the general consensus? Okay. What is it? Yeah, they're more specialized, is what I've run into. Everything comes to my mind, if you look for civil engineering, is a cliche of a guy in a hard hat wearing a suit with a roll of plans and pointing. And that's generally what you're going to find. And I hardly ever do that. Pointing. I don't know where he's pointing at. Over there. Roll of plans. Business suit. Any construction workers on that site, I don't know how they're going to really respect that man. I mean, dress down just a little bit. You don't have to wear a construction outfit, but it's just excessive. More pointing, more looking. I don't even know if he's really pointing at the building. Kind of at an angle. Architects. This one's a little better. He's dressed a little better. And that's for ones that are informed, but generally, I think they've done some studies, and they asked people on the street, what's an engineer? A lot of them think it's just a conductor, a locomotive engineer. So really, I mean, not a whole lot of people know really what engineers really do. They just know that things get built and my life goes on. We're the people behind the scenes. And this is where I spend most of my time, in a cubicle. I spend most of my time at a computer. I'm more of a design engineer. I do get to have some field opportunities and get to see some projects. But generally, as far as going out and managing the construction project, those are generally geared towards more of your construction engineers. And those can be civil engineers in those roles. So what makes a good engineer? Any ideas? Creativity, that's a good one. Ethics, that what it dedication, teamwork, intelligence. I hope by the time you got your engineering degree and you got your certification and licensure that you're fairly intelligent, or the education system has let us down. Anybody else? Okay. Here's just something that I came up with. A problem solver. Engineers are problem solvers. We answer tough questions. We do things that are specialized that a whole lot of people can't do, and they depend on our answers and our insights. Ability to communicate complex ideas. I try to work on this one all the time. When you're trying to describe something in 3 dimensions and you have to speak and talk about it, it can get kind of confusing. And you've got to have the ability to, 1, connect with the person that you're speaking to, and 2, they have to understand and correctly listen and know what you're trying to convey. Also, public speaking is another thing. When you become a professional, you might have more speaking opportunities. And for us, we have chances to be expert witnesses in civil cases. Looking to improve. This is one big thing that I try to do. I'm always trying to look for a better way to do something. Try to be more efficient. Make it more visually stimulating. Something that as soon as you see it, you have a grasp, an idea of what we're talking about. And sometimes you can get in a routine and trying to keep your mind stimulated and trying to make more progress. Opportunistic. You're going to have opportunities, and the ones that have success or get ahead are ones that are willing to do the things that other people don't want to do, and they won't shy away from it. They're willing to take on those challenges, even though they may fail. They know that if you keep trying, you'll have better chances, and you're going to learn a whole lot. And as somebody else is just sitting there, doing nothing or just doing their normal routine, I'm over here patting my stats and putting more things on my resume. Patience. This is virtuous in all areas of life. In a modern society with technology, communication available at our fingertips, we're pretty impatient. Projects take a long time to do, especially large ones, and you have to have the patience and fortitude to continue to press on. And modesty. I think arrogance is the mark of a fool. It doesn't make you a fool if you're arrogant. But those actions speak loud, and it's very foolish. So be modest, be humble, be willing to say when you're wrong, be willing to be the better person, and try to learn more and try to collaborate, work with each other. That's how you have true progress. That's how you have true prosperity. And I think that's been lost. So what about the schooling? I know right now the first semester I remember sitting in these seats, and the first year was fairly easy, but it will get tougher. It will get tougher. So you need to get ready. You need to get ready to work. You need to start preparing yourself. You're going to be pushed, but excellence isn't easy. Homework, you're going to run into people, going to have friends that are in other majors, and there's going to be times when you're going to say, well, I have a lot of homework I have to do. And if you want to do well, you're going to put in the hours, put in the time, and you might miss out on some things, but I can tell you that it's very rewarding. That day when you get your degree, your diploma, and you walk across the stage and they call your name, and you know that you have graduated from an engineering program. And really, when you do this, you're really set apart, and you're starting to join a special group of people, one with unique abilities, unique skills, skills that are marketable, skills that are in demand, and it's really a good group to join. So just some general advice for engineering students. I've heard some discussion, talk about student organizations and upperclassmen and getting to meet them. When I first got here, I always talked to upperclassmen. I was always asking, what do you do? How do you prepare for things? What is this professor like? What's going to be expected of us? Get expectations, and they'll tell you, and they'll help guide you. If they don't, I'm sure there's another one that probably will. When you're in class, don't be afraid to ask questions. Don't be afraid to ask questions outside of class. It's how we learn. It's how we grow. And I ask questions every day, even working. I recommend forming study groups. When I was in school, this is what we did. It helped to bounce ideas, see how people are doing things, so we can try to collaborate and try to learn more. That can be in homework and preparing for tests. And it's very beneficial because you get to know potential future engineers, and you're developing that network, and you're developing the ability to communicate with other engineers. Participate in student organizations. SAME is a good one. ASCE is a good one. It doesn't have to be one that's engineering oriented. It can be one that's on campus. Get to know other people from other majors, because in the business world and the working world, you're going to be dealing with people from different backgrounds, not just purely engineering. Learn to set your priorities. You're going to have classes. You're going to be juggling, like, oh, I got this homework, I got this test I got to prepare for. Setting your priorities of what you're going to do that evening. You're going to be faced with those challenges. So it's good to go ahead and start planning. Where's your priority list? What's number one? And down. And you got to work hard, but you really got to know when to relax too. Beating in a lot of hours, we get focused and trained in what we're doing, that sometimes we're not really as productive as we could be if we just relaxed and maybe got some rest. So as you go through the program, just remember that. Engineers and students, there's common jokes that go around with engineering. I just pulled some of them. Social life. You're going to hear jokes about, oh, I'm an engineer now, I don't have a social life. That's not really true, but your hours and time might not be with, hanging out somewhere. Another joke about free time. Being tired. You're going to go through, you're going to see people are tired, they're going to stay up late working on projects or homework. I think that's from Fight Club, right? Yeah. He looks pretty tired. I've been there. A common thing with engineers is everybody thinks you have the answers. They come to you, they ask you a question, they expect an answer. We're not magicians. We don't, we just pull an answer out of a hat. There's things we don't know, things we have to go and research and to learn. That's just part of it. And sometimes we're talking about that modesty and just saying, I don't know about that right now. but I'm a capable individual, I'm a capable engineer, and I will find it out. Just another thing about, what does your parents think? What do your friends think? What do I think I do? What do you really do? I don't remember having fries and, cola sitting there, but wanting to go to sleep on your desk, that's very real. And if you don't believe me, you can trust me. I'm a civil engineer, so it's okay. So now I've spoken about the disciplines and the schooling, some of my background. I'm going to go ahead and jump into where I work and the organization that I'm in. All the pictures you see here are projects maintained by the Department of Transportation. And within that is a division of highways. And this is really our specialty. This is really what we maintain as a division, as an agency. You got the New River Gorge Bridge, the Fort Hill Bridge there near Charleston. You got the South Charleston Bridge up in the top right, and it's just a nice scenic road through the highlands of West Virginia. So the West Virginia DOT, West Virginia Department of Transportation, its three main essential services to provide is transportation, tourism, and economic development. There's more than 6,000 employees that are part of the Department of Transportation, and it has 8 governmental agencies that are within it. Just an organizational chart for the whole department. Of course, you have the governor at the top, and then you have the Secretary of Transportation, which is a cabinet member, Paul A. Maddox, Jr. And if you notice, there's a slash there. Commissioner of Highways. He's also our commissioner for the Division of Highways. And the agencies are all at the bottom. And right there's Division of Highways. So let's learn a little bit more about the Division of Highways. Division of Highways has a lot of things on its plate, a lot of things that it has to handle and has to do. Planning's one, engineering, right-of-way, construction, traffic, any maintenance you have to do for your roadways. But we also have additional duties, research, roadside development, making sure everything's safe, disseminating, highway information, the likes. So a little bit of what we have to maintain, have an idea. There's 38,684 miles of public roads in the state of West Virginia, and roughly around 36,000 of that is owned by the state. So the Division of Highway is tasked with maintaining those roadways. That's a lot of miles, and I know people have run-ins with the condition of the roads and the problems that they see when they're looking at construction. I'm not out there. I'll get questions. You go visit a site or something. A landowner will come and talk about how bad things are, and it's really like, well, that's really not my job. I feel for you. I understand. We'll try to address those complaints, but there's also maintenance workers that have to go out as well. We have 88 miles of West Virginia Turnpike. We have some state-owned interstate highway, and we have a lot of bridges. There's a lot of various terrain in West Virginia, a lot of streams, and consequently you have a lot of bridges, and you have a lot of culverts. And a nice fact is that most of them are all greater than, a third of them are greater than 100 feet. And another big thing is, there's more than 4,800 employees. So it's a rather large organization. So here's our organizational chart of the West Virginia Division of Highways. It's kind of broken. You have our central office, which is where I'm from. I work in Charleston at the Capitol Complex. But there's also 10 districts that handle certain specific regions of the state. So first we're going to look at the districts. They have their district engineer, their district manager, their maintenance maintenance engineer, construction engineer, design engineer, and all their bridge engineers, and their own maintenance garages, people they have to manage. Here's just a breakdown of the districts across the state. I'm from District 1. I'm originally from Mason County. I live in Putnam County now, and I work in Charleston, Kanawha County. Here in Huntington, this is part of District 2. And you can view this online if you want. I put this map together to make it a little bit more appealing. So that was the districts. In yellow, this is more of central office. There's a little bit of overlap between the Deputy State Highway Engineer of Operations, but they also refer to the State Highway Engineer. Within the Highway Engineer of Development, we have different divisions, and I'm part of Engineering Division. So Engineering Division, this is their mission statement. I know it's a lot of text there, but simply put, Engineering Division is responsible for survey and preparation of construction plans and specifications for bridges and roadways. And they also have additional duties in notifying the public and conducting public hearings and meetings. So Engineering Division, there's 6 sections as we go getting down to where my unit's at. We have a consultant review, consultant services, technical services, in-house design, environmental, administrative. I've highlighted in-house design in red font because that's the section that I'm a part of. Also, those sections are subject to change as well because we've hired a new director and we're starting, there's a possibility of having some reorganization of some of the sections and how it's broken up. And really, in-house design, it's just responsible for projects that are determined to be done internally within the organization from a hired engineering staff. These are projects that are not put out for consultant design. And like I said, I'm part of a unit as we work down into where I'm located. There's 9 units. You have your roadway unit, your bridge unit. Roadways also project managers. They help to help facilitate and promote, communication between the various people that are working on a particular project. You have your bridge technicians who help draw the plans. Hydraulics and drainage, which is what I'm a part of. The geotechnical unit, structural repair. Structural repair just deals with maybe like bridge deck overlays and straightening of beams. Perhaps maybe like a vehicle has crashed into one of the barriers or the parapet. There's also a district review and design unit. They help orchestrate and assist the district in their review portions of the project. QA/QC, this is quality assurance and quality control. They're kind of a wide range. They help with maintaining the quality of reviewing our projects along with reviewing some things for consultant review, and they kind of specialize more in the bridge structures. And then there's an interagency that works with the other agencies like the Port Authority, help communicate and help facilitate interactions between the Division of Highways and the other divisions within the Department of Transportation. So the hydraulics and drainage unit, it's kind of our mission statement. We produce hydrologic and hydraulic analysis and design. We generally call it H&H. We also have a role in helping the districts. We're kind of multifaceted. We help the districts. We provide expertise to not just at the district level, but other agencies and other divisions as well. So just a overview, we have a lot of responsibilities. Like I said, we've done provide expert witness testimony in legal cases brought up against the Division of Highways. We have to maintain the West Virginia DOH drainage manual. We coordinate with other federal, state, local municipalities, certified floodplain managers that are located in counties across the state. We also do educational, seminars and classes to teach people in our building and at the district level some of the new things, some of the best practices for doing hydraulics. And we also do some consultant review. We can do initial design. I've reviewed plans for land development projects that are private. I've also reviewed projects that are put out for consultants to design. Reviewed that as well. We also develop, standard practices, special design practices, construction details, anything that has to deal with drainage. We're part of, professional subcommittees and councils. Like I said, we assist the district, and we also supply wetland and stream mitigation. We do natural stream design. Generally, this stuff has to do with environmental impacts and trying to mitigate environmental impacts, or to correct something that's been done wrongfully. So just some of my work experience, my project experience. I've done bridge and culvert hydraulics. I've done regional and urban hydrology. It's predicting the runoff and discharge values that go into the hydraulic design process. Done consultant review, like I said. I've assisted on one legal case, more of just as a field hand and as an advisor, just for the reports and things that were put together. I've performed supplemental field surveying, hoping to expand upon that a little bit more with our unit so that we can get additional data easier and faster. I've helped develop some standards for the drainage manual, looking into updating some of our methods for our curve numbers. That might not make any sense to you, but just coefficients that we use in our hydrology calculations. I've taught culvert classes, bridge hydraulics courses. Probably going to be teaching a hydrology course here soon, and I've also had the ability to go and present in other areas. Still working on some natural stream design. Actually, I'm going to cover a project that we've done there and help develop practices for engineering software. I'm one of the guys that kind of leads the charge on wanting to incorporate new software and what's the best way to go about solving our problems. So it's not just work. There's other things I've been able to do. Traveled to Nashville, Tennessee for some training. Attended a Bentley conference in Michigan. I've got to tour the inside of the South Charleston Bridge. Participated in the New River Gorge Bridge Walk. Presented at a national, I didn't put that on there, but I presented at a National Hydraulic Engineering Conference just this past August. And then I've had the opportunity to speak to you today. This is inside the South Charleston Bridge, a very large structure. Unfortunately, on that project, a man died, and it's just a plaque to commemorate and remember his efforts on the project, and just as a general, builder of bridges. That was his occupation. This is from the Bridge Walk, New River Gorge. It's pretty high up. So hydraulic engineering, that's kind of really what I do, and really just hydraulic engineering is we deal with flow mechanics and flow dynamics of water in large quantities, and a big thing for the Division of Highways is stormwater management, drainage from our roadways, ensuring that our bridges and our crossings are hydraulically efficient and don't try to create any negative or adverse impacts to surrounding properties. Tools of the trade. I put the old noggin on there, the brain. You know, we have one, but you'd be surprised at the stupidity that's out there. So don't get in that routine. You know, use your brain. You have one. That's your greatest tool. We have professional publications, AASHTO, Federal Highways Administration. There's technical journals and reports. The power of the internet. We have one-line resources, and we also have our own drainage manual, and we have drainage manual from other states. Previous experience is another good tool, and some computer software. Do you have some problems? This is what engineers do. We solve problems. Bad culverts, failed culverts, crazy construction. I guess they ran out of materials. They didn't have enough different adequate pipe sizes. I'm not real sure. Slides, these can be caused from water issues as well, not just being on the side of, on a hillside. It's probably what this one was more of. Major flooding problems. It causes, you can see it causes damage. So this is when we get the call. So engineers solve problems. We think critically. Utilize your education. You have your creativity and ingenuity. And we just serve for the public betterment. A lot of people don't know, our impacts in our lives. Here's just a slide near Welch, some real projects, some of the construction that was going on. Just because of time, I'm going to run through these a little quicker. The 460 sinkhole, this formed. We got a call a week later. It fell in. This project's actually about to go out in a week. Jaeger pipe, it's a little bit different because we have to daylight the pipe over a hillside. This is a multiple broken back culvert, and as you progress in your engineering, you take more hydraulic classes, maybe you'll talk about broken back culverts. This is a unique design, analysis situation. I was part of that. Cup run, just some inlet conditions. Inlet's the entrance, outlet, these are exit. A nice scour hole formed here at the exit of pipes is kind of common, especially for undersized pipes. Major flooding issue, if you remember that tree, apparently the culvert's not doing its job and causes damage. Kind of our microstation drawing. We're proposing a channel change, a realignment, and a nice box culvert. And here's some of our bridge hydraulics. Nice old bridge, 1912. Has a floodplain connectivity. It's more of a perched bridge structure. Kind of our microstation tools. Some of our proposed design. Some of our reporting that we have to do. I write a lot of reports, wrote a lot of reports in college, still do now. And some of our outputs from our HECRAS modeling software. As was mentioned earlier, there's interning and co-op opportunities. It's good experience building. You get to apply what you know, what you learn from each year that you're in school. You get to network. That's a real big one. And it's also available in public and private sectors. You can go online to the summer co-op program by visiting this website. Best of luck to you. Best of luck to you. Sorry, I went a little long.
No, that's all right.
wish we had more time to go through your slides. You had some awesome pictures there.
Thank you, sir. You said Dr. Salam?
Yes, Assad said.
Assad Salam? Salem, okay.
Where were